Let's take a quick look at what we call the average rate of change of a function. And we've talked about how we describe intervals as being increasing or decreasing. For example, here we have a decreasing interval from negative infinity up to 0. And then this function, this purple function here from 0 to infinity, is increasing. Now we want to describe how much it's changing, so we call that the average rate of change. Okay. The average rate of change is just this. It's a ratio defined by the change in y over the change in x. Or we like to use this Greek letter delta here as an abbreviation for the change in. So we have the change in y over the change in x, delta y over delta x. And so that is just the change in the y values, which is f of b minus f of a. And that's over the change in the x values, b minus a. Okay, so this is on some interval a, b. So, for example, on this graph here, we have the function f of x equals x squared. And we want to find the average rate of change on, so we want to find delta y over delta x. And let's say we want to find this on 1, 2. So that is the interval from 1 to 2 for our x values. Okay. So keep in mind these are, this is our a value. Our a is 1. And so this is our a. And this is our b. Right there. So let's use our function, or our definition here. Delta y over delta x is f of 2 minus f of 1 all over 2 minus 1. Well, since this function is y equals x squared, f of 2 is just 2 squared, and f of 1 is 1 squared all over 2 minus 1. So we have 4 minus 1 all over 2 minus 1, which is simply 3 over 1, which is 3. And there's our rate of change. So we say that this is changing at this rate of 3. Now let's think about what we just found. What we just found out here is the y values are going up 3 and the x values are going right 1. And hopefully that sounds familiar. We're really just finding, you got it, the slope. So we're going up 3 and right 1. So we're finding the slope of this line that goes through the points that are the endpoints of the interval. So we have the point here which is 1, 1, and the point here which is 2, 4. And those are the points on the function at our endpoints. Okay, the endpoints of the interval. And this line right here, we have a special name for this kind of line. This line right here that's going through those 2 points is called the secant line. So it turns out that the rate of change is simply the slope of the secant line. How about one more? Let's look at f of x equals x cubed. And we want to find the rate of change, the average rate of change for the interval 1, 2. So we have this graph here. Now we got to watch out here because the scale's a little different. We're going by halves here, and we're going by ones going on up here. So we have our interval 1, 2, which is going from here 1 to here 2. And we can notice the points right up here, from here to here. Alright, let's go ahead and use our definition. Delta y over delta x is the change in f of b minus f of a all over b minus a. Okay. And once again, here's our a value is the first value, and our b value is the second value in the interval. So we have f of 2 minus f of 1 all over 2 minus 1. And since our function is f of x equals x cubed, we have 2 cubed minus 1 cubed all over 2 minus 1. And that gives us 8 minus 1 all over 2 minus 1, which we have 7 over 1, or 7. And there's our rate of change. Delta y over delta x is 7. So we have a much quicker rate of change on this interval than we just had on the x squared, which we would kind of expect because when we cube things, it changes more quickly, at least in this interval. Different story on the interval between 0 and 1. Graphically, we can look at the secant line, and if we draw in our secant line something like this, as we said earlier, the rate of change is just the slope. So if we look at the slope here going up and over, remember that our scale here, we got to watch out for that. So we're going up 7 and over 1. Okay? So our delta y over delta x using the graph would be 7 over 1, which is what we expect. So the graph confirms what we got using the formula, and that is the rate of change. Now one last thing here to watch out for. If the rate of change is going up to the right, we have a positive rate of change. If we have a graph where we have some rate of change going down to the left, what would you expect there if we had some function like this? And we wanted to find the rate of change on this interval, the rate of change between these 2 points. Well, pretty clearly, remember the rate of change is the slope of the secant line. So if we're finding the slope on a decreasing interval, then we're going to have a negative rate of change. So a decreasing interval will give us a negative rate of change. Okay? And if it's increasing, we have a positive rate of change. All right. There you have it.